Welcome students. Actually, before summer vacation, we actually complete our first chapter, that is matter. Okay, and I hope everyone's exam has been good. Okay, so today we are going to discuss our second chapter, that is physical quantities and measurement. Okay, here at first we have to know from this chapter that what are the learning objectives. First one is, here we know the definition of length, mass, time and temperature, the quantities that are really connected or that are really actually meaningful for our everyday's life. Okay, and also we know about symbols, units and measuring instruments of length, mass, time and temperature. Okay, in generally we always in our daily life use uh, the length, mass, time and temperature. Okay, so that's why we at first we have to know the symbols, units and measuring instrument. Second, we just know measure length of an object using a ruler and a measuring tape. A ruler and a measuring tape is the measuring instrument to measure and the length of an object or any uh, body. And the second next one is measure mass of an object using a beam balance and an electronic balance. Here also beam balance and electronic balance is measuring instrument to measure mass of an object. Then measure time using a clock, watch and also by a stopwatch. Next, relate temperature of a body with its hotness and coldness also. And next, measure temperature of an object using a laboratory thermometer, and also using clinical thermometer we actually just measure temperature of a person also. And next, definition of area, unit of area, also measure area of a regular object and also measure area of irregular object using a graph paper. And finally, we have to know about convert a physical quantity from one unit to another related units. Okay, so these are the learning objectives from this chapter 2. Okay, so first we have to know measurement. What is measurement and what is its importance? So first one, actually measurement means we just tell that measurement is basically a process of comparison. Comparison of what? Actually comparison between two same type of quantity or same actually kind of quantity. That means suppose take we take a length, like the length of the body, suppose we take 5 meter. Okay, and another we take another body, the length of the body is 1 meter. Okay, so first one for body number 1. Okay, this is body number 1 and the second one body number 2. So here if we compare the two body, then we can say that the length of second body is 1/5, okay, of the first body, or we can say that the length of body 1 is the 5 times of length of the two body. Okay, so in generally for measurement we need a universally accepted unit. Okay, then we find how many times that unit is contained in a given quantity. Okay, like actually suppose we take two things, one length and another one is mass. then we cannot compare length with mass. Okay, so if we want to compare length, then we have to take two same kind of quantity, like two length, two mass, okay, or two temperature. That's why we can compare the two same type of quantity. Okay, and to express or to calculate any quantity, a measurement needs two things. First one is the unit and the second one is the number. Okay, so first one is unit and the second one is the number, which tells us how many times that unit is contained in that quantity. Thus a measurement is expressed as n into u, where n is the number, okay, and the u is the unit. Suppose the length of one man is like 5 feet. Okay, this is the measurement of any measurement of height of any man. Then we can say here 5 is n, okay, and feet is unit. Okay, so in generally, if we take one standard unit like 1 feet, then we can tell that the length of the man actually 5 times of the 1 foot. Okay, so we can compare easily and we can find out or we can measure the length of any body or any man with the help of this formula n into u. Okay, now in generally, there are several types of unit, okay, or there are several systems of unit also, we can say. Like in generally, if we take as systems, okay, of unit, here you can take as three systems of unit. One is cgs, and second one is si, that is also international unit, that is also known as mks, and the third one is fps. Okay, so the unit must have the following properties. Like first one is it should be of convenient size, and the second one is it must be universally accepted. Okay, its value must remain same at all places and at all times. Okay, it should not change with the change of place or time. Okay, that's why we can take as unit. Like if we take one unit, like suppose for length, the unit suppose we take meter. Okay, in SI system the unit of length is meter. So if we take 1 meter, then it must be universally accepted and the value of 1 meter remains same at all places and at all times in the universe. Okay, that's why we take it as an unit. Okay, otherwise we can't define it as unit. So the units must have the following two properties. This is very important. First one is it should be of convenient size, and the second one is it must be universally accepted. Okay, now what is the definition of measurement? Actually we already discussed. Measurement is a comparison of an unknown quantity with a known fixed quantity of the same kind. Okay, this is very important. Same kind, same kind means if we want to compare the length, then we have to take two length. Okay, or if we want to compare the mass, then we have to take two mass. Okay, so that's why actually we can easily compare and we can actually take as measurement. In generally, suppose if we take a standard value of length, that is 1 meter. Okay, then at first we just find out the length of any body, okay, and compare with 1 meter. That's why we actually make measurement. Okay, the value obtained on measuring a quantity is called its magnitude. Like we take 1 meter standard value, then we find out the length of any body, that is 10 meter. Okay, so we can say that here 10 is the magnitude. Okay, here 10 is the magnitude, and the length of the body is 10 times of the standard unit, that is, or standard value, that is 1 meter. Okay, in this process we can define the term measurement. Okay, now here we can see that three different system. Okay, first one is fps, second one cgs, and third one mks. Okay, so fps means here f defined as actually foot, and p means actually pound, and the third one, that is s means actually second. Okay, in this system. And here also cgs system, in cgs system c means centimeter. Okay, and g means gram, and s means second. Okay, so the last one actually mks, m means actually meter, k means actually kilogram, and s means actually second. So for these three system of unit, you can see that three actually symbol that is used in system of unit, that is basically the SI, sorry, the unit of three quantity, that is first one is for length, second one is for mass, and the third one is for time. And also you can notice that the in the three system of unit, for a time actually we just get same unit. All these three system, we just get same unit, that is second. Okay, otherwise for length we actually get different unit like foot, okay, centimeter and meter, and for mass pound, gram, and kilogram. And here you also you can tell that actually mks known as SI system or international system. Okay, in generally nowadays we uses always mk system. Okay, so here also we have to know about some symbols like foot. In generally we use ft, okay, in small letter ft. Okay, and for pound we just use lb, that is the symbol of pound, and for second we just use small s. Okay, and for centimeter we just use cm small. Okay, gram, gm is the symbol of gram, second we already know s. And for meter we just use small m. Okay, for kilogram we just use small k and small g, and second we already know s. So these are the actually three unit system. Also we just know the all the units of different quantity like length, mass, and time. Now we just move the next portion, that is basic physical quantity. What is quantity? In generally the quantity that can be measured is called physical quantity. Okay, so the quantity means that can be measured. Okay, in generally here we just see there, here we use total four quantity. First one is length, second one mass, third one time, and fourth one temperature. Also in our universe there are several numbers of quantity, like we can find out area, so it is also quantity. Okay, volume also, okay, it is also quantity. Density also, okay, density, and energy, okay, power, okay, etc. All these things are quantity because these are quantities because they actually they are measured, okay, by any process. Okay, but if we take as like smell, okay, we cannot actually define smell, or we can the smell cannot be measured. That's why smell is not a physical quantity. Physical quantity. Why? Because actually smell cannot be measured. Okay, otherwise here we can see length, mass, time, temperature, area, volume, density, energy, power. Also we take force. Okay, all these things are quantity because they can be measured by any process. Now here we just use a table, okay, for easily understand different physical quantities, their units and also their symbol. So first, for length we just use all these units in actually SI system or MKS system. Okay, so for length we use meter and the symbol small m. Next, for mass, kilogram, symbol is kg. For time, second, symbol is s. For temperature, actually SI unit is Kelvin and symbol is K. And electric current, ampere, symbol is A. Luminous intensity, candela, symbol is CD. And the final one, that is amount of substance, mole, SI unit, and symbol is MOL. In generally in our book, actually first four is in our syllabus, so we have to just remember first four. Okay, that is necessary for this chapter. Okay, length, mass, time, and temperature. Now in generally sometimes we can see that the size of SI unit to express any physical quantity is not of a convenient size. Okay, it is either too small either or too big. That's why we just use submultiple or multiple of units. Okay, so here again we can see one table, that is, so left side actually used for mass, okay, and right side is for length. Here from this case actually we can see that gram is CGS unit of mass. Okay, so above you can see that kilogram, then hectogram, then decagram, okay, then gram, okay, then decigram, then centigram, and also then milligram. So if we take gram as a standard value, then or standard unit, then you can say that the decigram, centigram, and milligram, these are the sub multiples. Okay, so these are the actually sub multiples, and the top three, that is kilogram, hectogram, and decagram, that is actually multiples of gram. Okay, similarly for length, we if we take meter as a standard value, then you can say that decimeter, centimeter, millimeter, that is some multiples, and kilometer, hectometer, decameter, these are the multiples of meter. Okay, so in generally we have to convert one unit to another unit, that is required. Okay, when we do not find any convenient size of SI unit, then we just convert the units using some multiples sometimes or sometimes multiples. Okay, so first here you can see that converting length. Okay, so we just use a diagram, that is first one we take kilometer. So here you can see that from kilometer to meter we have to multiply with 1000. Okay, so if I take 5 kilometer, then 5 into 1000 is equal to 5000 meter. We get the meter unit. Okay, so if we convert meter into centimeter, then we have to multiply the numerical value with 100. Okay, then if we want to actually find out centimeter to millimeter, then we have to just multiply the value with 10. Okay, so similarly in the back process, if we want to go millimeter to centimeter, then we have to divide by 10. Okay, and if we want centimeter to meter, then we have to divide by 100, and if we want to go meter to kilometer, then we have to divide by 1000. Okay, so these are the process to convert from one unit to another unit. Like suppose if I take actually 10 millimeter, okay, is equal to how much centimeter, then we have to convert millimeter into centimeter, and you can see that millimeter to centimeter means actually divided by 10, that is 10 divided by 10, so the answer is 1 centimeter. Similarly, if we take 100 meter, that is equal to how much kilometer, then you can say meter to kilometer also you have to go meter to kilometer, that means divided by 1000 is equal to 1 by 10 kilometer. Okay, so this is the answer. In this way you can actually easily find out from one unit system to, or you can actually easily convert one unit system to another unit system, or one unit to another unit. So next, there are some convention while writing the SI units. Okay, so first one is the symbols other than the name of the scientists are always written in small letter. Like suppose we take unit of length, that is centimeter. So we just use small c small m. This is the correct. Okay, or if we want actually, if we use SI unit of length, that is meter, just use small m, not capital. Capital is wrong. Okay, so here you can see we have to use always small letters when we use symbols of any unit, okay, other than the name of the scientist. Next, some units are named after the scientist. In such case, units are written in lower letters. Like if we want actually, if we take as the unit of current, that is ampere. In generally, the name of the scientist is ampere, but the unit is named after the scientist. That's why we just write down in small letter ampere. Okay, if you write capital A M P, then this is wrong. Okay, so ampere is the small a, M P is the right. Okay, next, symbols for a unit named after a scientist is always written with a capital letter. Like suppose we take a unit like actually force. Okay, so SI unit of force is Newton, so you just use capital N. Okay, here Newton is the name of the scientist, so you have to use capital N. Okay, capital N is the correct. If you use small n, then it is wrong. Okay, next we move to fourth point, fourth convention, that is the unit and its symbol are never written in plural form. Like if you actually use length of one body is 10 centimeter, then you just write 10 cm, not 10 cms. Okay, or in 10 meter you just use 10 m, not write down, not to write actually 10 ms. So this is correct, this is wrong. Okay, so we cannot use actually plural form of unit. Now the fifth convention, in words the unit is written in small letters. Okay, so if you write down some unit in words, then you just write down in small letter. Like if you write down centimeter, then you just write centimeter. Okay, this is the correct. Otherwise, if you write down capital CENTIMETRE, then this is wrong. So if you want to write down the unit in words, then you have to write in small letters. Next, a space is left between the symbols of two units when they are used as product. Okay, so if you use two units as a product, then you have to give one space between them. Like suppose if we want to multiply Newton into second, then you just write down n, then a gap, and you use s. Okay, so this is the product of Newton and second. So this is the correct. And also the last one, seventh convention, that is negative powers are used for the compound units formed by dividing one unit by another. Okay, like suppose if we take one unit like meter per second or meter divided by second, then we can use or we can write down ms to the power minus 1. So in this case, this is right also. So negative powers are used for the compound units formed by dividing one unit by the another. In this way, actually we have to write down units. So when we want to write down some units, then we have to remember all these conventions. Okay, next we are going to actually find out or measure the length. In generally, length means actually the distance between 2 points. If we take 2 points, one is A and another one is B, then the distance AB is actually length of AB is the distance between A and B. Okay, in generally the SI unit of length is meter. Okay, small m. So you have to know about the definition of 1 meter or a meter. In generally, previously actually the first definition that is used, a meter was initially defined as the distance between 2 points on a rod of platinum alloy that is kept at 0 degrees Celsius in the International Bureau of Weights and Measures near Paris. It's actually Sevres. Actually, this is very old definition. Today we just uh, we have to remember the second one, that is very important. The meter is defined as the length of the path traveled by light in a vacuum during a time interval of actually 1 by approximately 3 into 10 to the power 8 of a second. Okay, of a second, or you can use the term also. Okay, so in generally this is the definition of 1 meter. The meter is defined as the length of the path traveled by light. Okay, so these are the definition of 1 meter. Okay, next actually we discuss in the this is the end of today's class. In the next class we discuss about actually some multiples and sub multiples of length and their relations. Okay.